Okay. Hey, good evening, everyone. Today we are going to discuss about bind research main intuition and also with some secret problems. Okay. So basically, this session is going to be we are going to cover from the basics. Okay. So initially we are going to start with the basic like why do we need bind research algorithm. Okay, and after that we're going to see what is the catches about what are the different variations of binary search, like you know like everyone has like binary search only for sorted arrays, right? Everyone have their in my mind in their mind binary search is going to be used for only arrays, but we are going to see the other problems as well. Okay, so let me go through agenda of today's session. Today's session will start with why do we need searching, what is the importance of searching, uh, and after that we are going to see a traditional way of searching known as linear search. Okay, so and since linear search has some its limitations, like some its boundaries, we are going for a binary search. Usually, there is different kinds of searches as well. Like not only linear and binary, they are going to be ternary. One minute. Uh, okay. So in linear search, we have some limitations that we are going to discuss in this session, and after that we are going to see we are going to see what is the binary search and how do we implement along with the algorithm. Also, we are going to discuss about the time complexity of the binary search, and then we are going to discuss some problems. Now, after doing some glimpse about the binary search and traditional searches, everything, we are going to see about when to apply binary search. This is very very important. Like I'm going to discuss about when to apply binary search. Usually, what happens is people think binary search only for arrays or else sorted elements, but we are going to see some some flavor of binary search that is apart from like linear I mean sorted arrays. Okay, and we are going to see some secret problems, what are the secret problems are it is related to uh, it's those are not traditional array questions. Okay, yeah, let's go with the agenda today. So today our first topic is about discussing about linear search. So before going to discuss about linear search, I want to know what is the main purpose of searching. The main purpose of searching is to find something, right? To find something. Like uh, let's say I want to search for a word. Uh, let's say I want to search for let's say data in dictionary. So in dictionary there is going to be a lot of words, I believe. So how do you going to search this word? This is the word you want to search in the dictionary. How do you search? First you are going to take all the D letters cowords, and after that we are going to take A letter starting words. So we are going to filter in every stage. If you see this kind of filtration you are doing, right? Why? How you are doing this? Because dictionary, you already know, dictionary is arranged in such a way that it is ordered in A to Z. likewise in real life as well, if you want to search something, you need to arrange it, right? Okay. So let's say, uh, let me go through linear search ka thing, and after that I'll come to the same stage. Okay. So what is the meaning of linear search is, let's say I have an array that is consisting of some elements. Okay. So I have this array. Now let's say I want to search for a key, like I want to search for 11. So how do you search? You can give is you're going through a simple for loop, I less than n, where n is the size. Okay. Now you're going to check whether every element is equal to key or not. So if it is equal to key, then what you are doing? You're going to give true. Okay. This is like basically a simple linear search. Simple linear search, isn't it? So just simple linear search. Okay. What is the disadvantage of this? Before going to disadvantage or before going to limitations, we want to see what is the main advantage of this. The main advantage of this is like, let me discuss the advantages before going to disadvantage. The main advantage is we are iterating through, we are iterating through all the elements. We are iterating through all the elements. That is the main advantage of it. Okay. But what happens, let's say, if element is not found? What is the disadvantage? I want to say disadvantage as well. So what is the main disadvantage is, what happen, let's say if there is no such element is found, then you're wasting, you know you're wasting logic to search by iterating all elements, right? By iterating all elements. So here linear search is having one big advantage. Like what is that advantage is, like you are going to check every element, so that you are make sure that you are checking every element in the data in order to search something. Okay. But that advantage is itself a disadvantage. That advantage is itself a disadvantage. Why? Because we are wasting logic to search something, like in order to check whether the data is existing or not. That is itself a big disadvantage, no? Okay. That is the main big disadvantage of it. Let me give some scenarios. Let's say, let's say we are having a shoe factory. We're having a shoe factory, and in the shoe factory every day, like 1 million shoes are 1 million shoes are manufactured, and every shoe has unique ID. Every shoe has unique ID. But what happened is, let's say some shoes are missing. Now, in order to identify that, you need to search. You need to search. You need to search every ID for 1 million times, right? Every ID for 1 million times. So usually what happens in order to search, let's say manufacturer identified 10 shoes or defects, 10 shoes or defects, then you need to run this algorithm for 10 million times just for searching. This is just for searching. Okay, so for just for searching, you are in like you are using resources uh, almost 10 million times. You're going to you know 10 million times you are going to take the time, right? So that is the biggest disadvantage of this linear search. Okay, and what is the time complexity of linear search algorithm? Time complexity is always order of n, where n is the size or space, size or space you are searching. You are searching for. Okay. Now let's go for binary search intuition. Okay. So what is the main intuition of binary search is the name itself is suggesting like we're doing binary. Binary means two, either this side or that side. Okay. Let's see what is this side and that side. Okay. So we are searching either in one side or other side. Okay. Let me take in the form of array. Let's say this is my array. I'm going to search now. You know, um, binary search will always divides search space into half. Okay, now I can say this is my lower boundary and this is my higher boundary. Okay, now it is half in the way of mid. Now let me name these spaces. Let's say this is space 1 and this is space 2. Now every time you are going to eliminate one space. Either you are going to eliminate this space or you are going to eliminate this space. That is based on the condition that you are trying to search. Okay, so this is the main intuition of binary search. Binary search the main intuition is, let me write it. Binary search the main intuition is divide search space by half. Divide search space by half by eliminating one space. Okay, so here I am so many times I'm saying about the space, right? So what is the space exactly? Space is the logical boundary. Space is the logical boundaries that we are searching. Okay, so we'll see what is the logical boundaries that we are searching. Okay, but initially, like I want to give you an intuition like why do we need binary search earlier. Like I discussed about linear search and its disadvantages and limitations. Usually what happens is linear search advantage in itself is becoming disadvantage there. Okay, and I discussed about like what is the need of binary search now. Usually, what happens is binary search is always dividing search space every time by half. Okay, that is the main intuition. Now, in order to divide this, I said this space is logically arranged, right? So, how the space is logically arranged? Space is logically arranged, I said. Okay, so how the space is logically arranged? These are logically arranged. So how this space is logically arranged? In sorted manner, right? In sorted manner. Okay. So this is the main important thing. The space should be arranged in sorted manner so that we can eliminate one space by cross checking it. Okay. Uh, by searching it. Okay. So earlier in linear search, what we are doing? In order to search for something, we're iterating through all the elements, right? We're iterating through all the elements. But here in linear, in binary search, we're not touching all the elements. We're touching, you know, we're touching the elements based on the conditions. Let's see how it works. First, we will try to see the binary search algorithm, okay, and we'll build discussion on top of it. Great. Let's say I have an array consisting of 16, 18, 6, 5, 15, 11, 12. Okay, now this is my array. And it has indices 0, 1, 2, 3, 4, 5, 6. Now let's say I want to find a key 11 again. In order to find this key 11 is existing or not, so what is the first thing that we need to do? The first thing is this array need to be in logically sorted, right? Logically sorted. So what is the meaning of logically sorted? Like my space is in such a way that it need to be in the sorted manner so that I can eliminate one half of the space at every time that I am iterating. Okay, so after sorting it, how it look like? 6, 11, 12, 15, 16, and 18. Okay, along with the key as 11, and the indices are 0, 1, 3, 5, and 6. Okay, now let's try to do binary search. So basically what happened is, as I said earlier, binary search has two spaces. Since it has two spaces, we name it as a binary search, right? So what is the two spaces? That two spaces has been created by using low and high points. Usually it can be interchangeably with L and H, and some people may start and end. So many norms for this. Okay, so usually this low is pointing to the starting element and high is pointing to the ending element. Now 0 and 6 are there, so usually middle element is like this. This is the middle element. So these comes under the space 1 and this comes under the space 2. Okay, now what happens here? Like initially my low and this is my high and this is the mid. Now we are going to operate based on this. Okay, we are going to operate based on this. So what is the mid here? I'm talking about every time mid and separating the spaces into the half. Mid is the name itself is suggesting. Mid is the middle portion. Like how can I calculate mid? I can calculate mid by low plus high divided by 2. So it is the middle element of low space and high space divided by 2. Okay. So what is the low here? It is 0. And what is the high here? It is 6. Okay. Now what is the mid here? You are getting mid as 3, right? Now here, what is the AR of mid here? AR of mid is 12. Now can you tell me, we are going we need to search for key 11, but we got 12 now. Like we are in 12. Now since this is strictly increasing order, this is strictly increasing order. Now we are at here. It is saying that we exceeded the given key. Now if we exceeded the given key, then which side we need to move? Either we need to move this side or we need to move this side. So we have two options. If we move this side, then we will get bigger elements from 12 only. Na? So the next going elements are bigger than 12 only. So we need to reduce the space in order to get the desired key. So how do you reduce the space? By making this high to mid minus 1. Okay. Now let make the high to mid minus 1. That is 2. Now what is the mid value now? Now the mid value is 0 plus 2. Let me write it. 0 plus 2 divided by 2, which is 1. Now what is the air of 1 consisting? It is 6. Now if you see this is surprising, right? Like earlier we got 12. Now what happened is we reduced the high such that one space is eliminated, so that our next value is definitely going to be lesser than this 12 only. But our desired value is 11, right? So we got 6. That means we went one step ahead than the desired value. Okay, so if that is the case, then what you need to do? Earlier we decreased the high to mid minus 1, right? Now what we need to do is we need to increase the low to mid plus 1. Okay, that means we eliminated the other space. Okay, let's say here we eliminated space 1, sorry, space 2. Now here we eliminated space 1. So what is the space 1 and space 2? Space 1 is related to low, space 2 is related to high. Okay, now what we are going to do, we are going to make this low as 1 and the high as 2 itself. Okay, now what we are doing, we are trying to do 1 plus 2 divided by 2. So it is 3 by 2, it is again 1. Now again we are getting 6, right? Now what we are doing, we are again making low as, like we are eliminating space 1 again, and again we are making uh, low as 2. Okay, now here high as 2. Now let's try to find the middle element, that is 2 only. Now air of 2 is 11. So if you see this, we got this 11 by simple iteration, by simple this number of iterations. Here we got 4 iterations, but usually what happens is, let's say I have a big array, I have a very big array. Now let's say I want to search this thing. Now what happens is every time I'm eliminating by first thing I am eliminating these things. Now again I am eliminating these parts, right? So every time I am eliminating, initially I am eliminating half of the size. Now after that I am going to eliminate half of the size into half of the size. Okay, so it keeps on going. So this will this will give the efficient way of searching. Okay, now you got idea, right, how the bind search will works. Now let's say what happened, let's say I want to search for 4, or else let's say I want to search for 7. I want to search for 7 here. Now what happened is, here this two will give 11, right? Now here I want to search for 7, which is not there. Then what I need to do, I need to make this high as mid minus 1, right? So here if you see this, low is 2 and high become 1. That means logically the names itself is suggesting, right, low is always lesser than equal to high. If it is crossing, then what you need to do, you need to stop doing binary search there, because this condition itself is saying like the element is not present in the search space, the element is not present in the array. Okay, yeah, I think it is clear. Okay, let's try to write the binary search algorithm. Let's say I want to check whether the element is exist or not. Okay, go binary search. So it will take array and key. Now what we are going to do? We need two things. One is low, that is the lower boundary, which starts with 0th index, and we need high, that is the upper boundary, which is length of array. Or else let me take one more argument here. Okay, so which is n minus 1. Okay, now what we need to do, we need to iterate through the array by taking the mid element. Okay, let's say I don't know when I need to stop, right? So if I don't know when I need to stop, what is the loop that I need to use? The loop I need to use is while. If you know when to stop, then you can use for loop. Okay, if you don't know when to stop, then you need to use while loop. Okay, while loop, some condition is there. Okay, so inside it, what we are going to do, we are going to take mid value, that is always low plus high divided by 2. Okay, now you are going to check. What you are going to check, you need to check if your mid value is equal to the key or not. So if it is equal to key, then what you need to return? You need to return true there, isn't it? You need to return true. If not, then you have two conditions. If it is written, then this is the happy case now. So you are returning true. If not, then what you need to do? You have two conditions. One condition is for eliminating space 1, other condition is for eliminating space 2. Okay, so space 1 is referred to low, space 2 is referred to high. So when you are eliminating space 1, if your value in the mid is less than k, then you need some bigger values, right? So how do you get bigger values? By making low value as mid plus 1. Okay, in the else condition, in the else condition, what do you need to make? You need to make high as mid minus 1. Okay, that is you are eliminating the space 2. Okay, so by this you need to do. So if it is not returning true in the loop itself, then you can assume there is no such element is present now, so you can return false here. This is the simple binary search algorithm, but we have written the condition now. So what is the condition that we discussed there? Here the condition is low is always less than equal to high now. Otherwise what happens is here your low become cross it it crossed the high, so that what happens is it will go in the infinite manner. So we need to cut down it. When we need to cut down, we need to cut down whenever low has been crossed the high. Okay, so that condition we need to put here. Let me write it. Low is less than high, less than equal to high. Okay, so this is the simple binary search algorithm that you need to use for search for something in a sorted array. Okay, now what is the time complexity of this? Time complexity of this is very intuitive to get it. Let me define in a simple manner. Let's say I have an array with the size n. Okay, let's say I have an array with size n. Now what we are doing, we are taking low and high. Okay, now we are taking mid. Now by taking mid, you are eliminating half of the array. How much you are eliminating? N by 2. Okay, now Another half you are eliminating. Let's say my high is become like this after some condition. Now let's say you are eliminating this half now. Okay. So how much you are eliminating now? Earlier you eliminated n by half of the array. Now your size of the array become n by 2. Now in this you are eliminating n by 2 uh, whole square. Na? So it is n by 2 whole square. Now again if you are eliminating something here, then it will become n by 2, or let me redefine it, n by 2 square. Okay, here it is n by 2 cube. That means you are reducing the size. Okay, you are reducing the size n by 2 every time. Okay, that means initially you are reducing the size n by 2. Now again you are reducing the size n by 2. Now again you are reducing the size n by 2. Again reducing the size n by 2. Let's say you have done by k times. Okay, you have done this by k times. Now after k times you can assume that there is nothing to search, like everything has been searched. So there is only one element to compare after k times. So how you can written this as, this written as 1. Now this can be written as, okay, as 1. How we are getting this equation? First time we are eliminating n by 2, next time we are eliminating n by 4, next time we are eliminating n by 8, and for k times we are eliminating n by 2 to the power of k. Okay, so we are eliminating yeah, every space by n by 2 every time, every iteration we are doing that. Now for k iterations, what happens is, let's say we can assume there is only one element to compare, then our equation will become n by 2 power k equal to 1. Now if I make this to this side, then n equal to 2 to the power of k. Okay, now after taking the logarithm on both sides, log on both sides, here log means natural logarithm. Okay, so log on both sides, then what you will get? You will get log 2 base n equal to the k. So what is the maximum number of k is the maximum number of times that you are iterating, right? So what is the maximum number of times you can iterate? It is log n. So overall the time complexity of the binary search algorithm is order of log n. Okay, that is the maximum time complexity that you that need to be take to search anything in the binary search. Okay, now let's go to the old problem that we have. What is the old problem that we have? In the shoe factory, every day we are manufacturing 1 million shoes, right? Now let's say there are 10 shoes that are defected, or else 10 shoes that are not there. Now in order to find these 10 IDs, what we are doing, earlier we are doing 10 million times, but now the all manufactured shoes in the logically sorted order, and it is distributing in the sorted way. So that what happen is, 1 million means, like, let's say 10 to the power of 6. Now for every iteration, then you need a logarithm of this. So it's approximately equal to, let's say, 6. I'm taking natural logarithm here. Okay, so it's approximately equal to the 6. So you need 10 times, right? So 10 into 6, it becomes 60 times. So in order to see the 10 IDs, you need 60 iterations. You need 60 iterations, just 60 iterations. Earlier you have 10 million iterations. Earlier you have 10 million. Now how much we reduced? It's almost negligible, right? It's almost million times. We reduced million times. That's why binary search is very important and very useful for searching an object that is in the logical space. Okay, although we have discussed about what is the logical space in the high level way by showing low and high, but we are going to discuss about logical space out of the arrays as well. Okay, great. Let me give you a question. Okay, this is the question. Now, let's solve a question related to the binary search. Okay, the question is, let me maximize it. Hmm, yeah, the question is like find the seal value of a given number in a given sorted array. So what it means? What is the meaning of seal is like, let's say seal is nothing but the top value. Like let's say you're standing on 3.5. Now seal ka 3.5 is become 4, nearest greater integer, which is equal to that or not. Okay. uh, okay, now let's say I want to have seal of 4. So what is the seal of 4? Seal of 4 should be 4 only, na? Because 4 is the nearest integer of 4. Nearest integer which is greater than or equal to the given number. Okay. Now let's take the example one. In example one, you need to search for 6, right? Okay. I'm sorry. You need to get seal for 6. Okay. Let's see in the array. In uh, this array is a sorted array, right? In the question they given this is the sorted array. Okay. Now let's go through every element. Okay. Let's go in the linear fashion. Is 1 is greater than or or equal to 6? That is not. So this 1 is not going to be my answer. Okay. Now I'm going to check the other element. 3 is going to be my answer? No. Why? Because it is not greater than or equal to my given number. Okay. And 5. 5 is going to be my answer? No, of course no. Because 5 is less than 6. Now 7. 7 is going to be my answer? Yes, absolutely. 7 is going to be my answer. Why? Because this is the number that is greater than the 6. Okay. And if I get this answer, then I don't need to check the other ones as well, right? So I can return the 7 here. Okay. Now let's go for another example. Let's say I want seal value of 0 in this given array. So what I'm going to do, I'm going to check this. So whether it is equal to or not. Yes, it is not equal to. Then I'm going to this number 5 minus 5. This is also not equal to. Then I'm going to 0, which is equal to the given k. Then what I need to return? I need to return 0 itself. Why? Because it is matching with the given number, right? So I can write seal is nothing but number equals to given number or bigger than that, or bigger than that. Okay. So a number which is equals to or bigger than that is known as seal value. Now you need to find seal value of a given number in the given array, and that array is in sorted manner. Okay, that is the simple question. Let's try to solve this. How do we solve this seal number? What is the main thing that we can follow? After seeing the question, the main thing is let observe something. Let observe something. What is the first observation that we can do? Array is sorted, right? Array is sorted. So if array is sorted, there is a then there is a logical space. Then there is a logical space for searching, right? Then there is a logical space for searching. Okay. So what is the logical space here? Logical space is array itself, right? Array itself from zeroth index to n minus one index. So this is the logical space. So now you have the logical space. You have the value. Let's try to define it. Okay. Let's try to take the same example 13579. Okay. Let's try to take 13579 is my array, and it is sorted with the index values as like this. And your k value is, what is this? Yeah, it's k. Your given number k is 6. Now, how do you define low value? Low value is always get by logical space. What is the logical space here? Zeroth index is the low, and n minus 1 is the high. So based on the logical space only, you are going to get which is low, which is high. Okay, this is the high. Okay, now let's try to define it. This is low, and high. You need to get mid values low plus high by 2. Okay, so this is low plus high divided by 2, and we also have pair of mid. Now let's say we have a seal value of k. Okay, now initially I don't have any seal value. Okay, now what is my low? Initially my low is 0, and what is my high? High is 4, which is lost index. Now 0 plus 4 divided by 2, it will give 2. Now error of mid is 5. Okay, now this 5, like, is this 5 is greater than the given key? No, right? So then this is not greater than my given key. Then what I need to do? I need to increase low in such a way that my next mid should always greater than 5, right? So how I can do? I need to make this mid value as mid plus 1. Now my mid become 3, and this become 4. Then it is 3 plus 4 divided by 2 is 7 by 2 will give 3. Okay. Now my mid value become air of 3, which is 7. Now if you see this, I'm getting 7, which is greater than 6, right? So this can be my potential answer. This is not my exact answer. This can be my potential answer. So if it is my potential answer, then what I need to make? I need to make 7 here. I need to store the value. Now I need to search for something like, let me take some more. Let me take one more example. Usually, what happens is, since you are getting the bigger number, uh, let me expand this array. Just a second. Okay, now it is become 5. Okay, now it is become 5, right? Now what happens is, let me, these things will change. Okay. Now this my high value is 5. Now 0 to 5, what I'll get? 0 plus 5 by 2. That is 2. Now my error of mid is 5. So this 5 is less than 6, right? So anyway, like this 5 is not going to be my answer. Why? Because it is less than the given seal value. Now what I need to do? I need to push this low space to mid plus 1, right? So I have pushed it. Now this is my new mid value. And what is the high value now? High value is 5 only because I have not disturbed this high value. Now what I need to do? I need to make half of this. So it is 8 by 2, 4. Then my error of mid is 9 now. Now if you see this, I am getting 9. This 9 is greater than 6, right? This 9 is greater than 6. Let's say I have I have 5 here. Then my answer is going to be 9 only because there is no bigger element. The nearest bigger element of 6 is 9 only, right? But earlier here I have 7. Now my answer becomes 7. So that here, if you carefully see this, we don't know like the previous values. We don't know what is the next comparison is going to be. So that this can be my potential answer. This can be my potential answer. So that what I need to do, I need to store this. I need to store this in C. Okay. Now what I'm trying to do, I try to go for uh, I try to cut down the high space such that this time I want to get lesser element this. I want to get lesser element this, but bigger than k. You got it? Like currently my mid is this. Now this 9 is greater than 6. I agree with it. But this is my potential answer also. But what happens is there is a 7 before this 9 now. So I need to get the 7. In order to get the 7, I need to move by saying high to mid minus 1. Why? Because this can be my potential answer if this is 5. But this cannot be my answer if it is 7 there. If in the third position 7 is there, then it is not my answer. Okay. So in order to cross check whether there is a element that is nearest to the given integer, we need to take the other mid as well. Okay. Now we are getting mid as 3. Now we are getting 7. Now if you see this 7 is lesser than this, lesser than this 9, and greater than this seal value 6. Lesser than 9, greater than 6. So which can be the seal value now? Like let's say I have 6 number. Now after this I have 7. Now after some time I have 9. Now, what is the seal value of 6 here in the array? 7 only. Na? Earlier, we are assuming 9 is my answer. But what happened is 7 is present, then we are taking 7. Okay. This is how like we need to find it. It's a kind of same binary search, but the thing is we need to do some tweaks. We need to add some tweaks to get it. Okay. Great. Let me write the algorithm for this. Seal of array. I'm taking in children and array along with the k. Okay, these are my arguments now. Now what I need to do? I also know the search space that is starts with low value as 0 and high value as n minus 1. Now what I need to do? I need to search in between. Let's say my seal value is nothing. Let me take my seal value as minus 1. Here, let me give the full the edge case for this, if there is no seal value is exist. I don't think there is no seal values are exist. But let's say I am given an array like this, sits, 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 sits. Now let's say my k is 7. Then there is no seal value for this, no? So in that case, you need to return -1 there. Okay. So in the edge case, you need to return -1. So for that purpose, I had initialized the seal value as -1. Now what we need to do? We need to run the binary search on this. How do we run the binary search? We need a while loop with always going to be check whether our low is less than high or not. Now every time we are going to take a mid. What is this mid? This mid is combination of low plus high divided by 2. And we are going to check if my mid value is equal to k or not. Then if it is equal to k, then what happen? You can directly return it. Or else, let me rephrase this. If it is greater than equal to k, then what you need to return? Instead of returning, what I'm going to do is I'm updating my seal value. I'm updating my seal value. I'm updating my seal value as mid. I'm updating my seal value as mid. Why? Because if this is greater than k, then what it means is, like, here I'm getting 9 now. So this 9 is greater than 6. Now what I need to do? I need to take this 9 and I need to move 5 to mid -1. I need to move high to, I need to move towards left direction, I can say. It is mid -1. Okay. Now in the else condition, what I need to say? I can say low as mid +1. Okay. And finally I can return what I need to return. I need to return seal value. Okay. So this is the simple binary search algorithm in order to find a seal value in the given array. Okay. Yeah. I think it is understandable. Let me add some tweak of this question. So what is the tweak of the question is, here I am asking for seal value, no? Seal value. Okay. Now instead of seal value, I want to, I want to find number of elements. I want to find number of elements which are greater than or equals to the given sorted array. To the given sorted array. Let's see what it is. Let's say I have an array. Let me take 1 5 7 8 9. Now k equal to 4. Now how many elements in this array are going to be greater than k? Here k equal to 4. Now how many elements are greater than 4? Here 1, 2, 3, 4. So 4 elements are there. So you need to return 4. Okay. That is the question. We'll discuss this question after some break. Okay. Let's have 10 minutes break. Okay, let's start. Let me revise what we have discussed so far. Okay, we started today's agenda, like why do we need search, and after that we discussed about linear search and its limitation, like how linear search is failing to search when it's going to be a bigger search space, and has seen the main intuition of linear binary search, how it had been taken, and what is the logical search space that we have discussed. Like we discussed the lower boundaries, upper boundaries, and mid values, and the search spaces related to this. The name itself is suggesting binary search, right? So it has two search spaces, and we are eliminating like search space every time. That things we had discussed, and after that we had discussed about binary search algorithm. That is a traditional algorithm to search in a sorted array. Okay, and after that we discussed about the time complexity that is going to be take on a binary search. Okay, and then now we are in discussing about the problems. Okay, the problems that we have discussed is like finding the seal value. Okay, so what is the seal value? Seal value is the number that is greater than or equal to the given integer. Like let's say I am giving 3.5. Now what is the nearest integer of the 3.5 which is greater than that? 4, right? Likewise, here we are trying to find seal value in the given sorted array. Now if you see this in this given array, k is 6, right? Now for this 6, what is the bigger number than 6 in this array? 7. Okay, now here k is 0, right? In this example 2, in this if you see this, what is the bigger number that is greater than or equal to the given number k? 0 itself. Okay, that is the seal value that we solved it using binary search. And after that, with the continuation of this question, I given like find the number of elements which are greater than or equal to the given sorted array, which are greater than or equal to the given sorted array. Like let's say I'm giving k equal to 4. Now in this array, how many elements that are greater than or equal to 4 now? There are 4 elements, right? There are 4 elements which is greater than or equal to 4. Now you need to return 4. Okay, now let's say instead of 4 I am giving 11. How many elements that are greater than or equal to the 11 here? 0 elements. So how you find it? The same algorithm, sealing ka thing, seal ka algorithm. Same thing. Let me write it. So before solving this, I said like in order to do something, in order to do binary search, you need to define a logical space, right? So what is the logical space here? Here the logical space is array itself from 0 to the given n minus 1 digits. Okay, that is 4. Okay, now here your low value is this and high value is this. Okay, now you need to search in this space only. So your logical space is defined and your intuition to find is defined. You need to find how to solve it. Okay, so let's have pen and paper in order to solve this and try to see the like how low and high is playing between them. Okay, let's take what is the initial low value and the high value and mid value that can be calculated by low plus high divided by 2. Also, I need array of mid value. Okay, let's say what is my intuition here? I need to find number of elements which is greater than or equal to the given number k, right? So let's say I have number of elements greater than k, so that I can name it as a answer. Okay, this is my answer. It holds number of elements greater than equals to given k. Okay, so this is my answer. Initially, what is my answer? Initially, my answer is 0, and initially my low value is 0. High value as n minus 1, that is 4. Now, array commit value is 0 plus 4 by 2. I'll get 2. Now, what is my array of mid? That is 7. Now, if you see this, is this 7 is greater than 4 or not? As it is greater than 4, right? Now, which index it is presenting in? At the second index, right? So that from second index onwards, everything is bigger, isn't it? From the second index onwards, everything is bigger. So I can assume now my answer got updated as, what is my n here? N is 5. There are 5 elements. Now, from the second index onwards, everything is bigger. Then what I need to do? I need to update it as n minus mid. So what is the n minus mid here? 5 minus 2. That is, there are 3 elements bigger than this. Okay, clear? Great. Now, you got 3 elements bigger than this, but if you see this, in this side, we have one more element which is bigger than this. So that our search is not completed yet. Our search is still not completed yet. We got a one kind of potential answer now. That is 3. But still, we need to search for something which have bigger elements as well, right? See, one thing you need to remember while doing binary search is your search space is not completed until low is crossing high. That is for sure. Okay, so let's search for which space we need to search now. Since we got we calculated we consider all these elements, then we need to search more elements by making high is mid minus 1. Okay, so now your low become is 0 and high is mid minus 1, that is 1. Now it is become 1 now. Okay, now AR of 1 is 5. Now if you see this 5 is greater than the given k, then this is also going to be a potential answer. Earlier your value is n minus mid, which is 3. Now your n minus mid will give 5 minus 1 will give 4. So it is bigger than this now. So what happens is I'll update my answer as 4. Okay, now again I'm going to search. Why? Because my low is still is lesser than high. Okay, how I need to do? I need to make this high as mid minus 1. Okay, so 0 plus 0 by 2, which is 0. Now my array of 0 is become 1, right? In 0th index I have 1. Okay, now if you see this is less than 4. Okay, this is less than 4. Now if it is less than 4, then what you need to do? You need to rise the low value. What? How much you need to rise? You need to rise the low value by mid plus 1, and your high is still 0. Now if you see these two things are cross checked. Okay, now you are not going to update anything there. Your answer is still 4. Now you are returning 4. Okay, clear? Got it? Yeah. Now let's try. I think you understood this, right? Okay. Let me take one more example. Let me take small values 1 and 1 and my k also 1. Now, how many elements which is bigger than 1? 2, right? Let's try to dry run this. This is your low value. And I made along with array of made and your answer. Initially, your answer is 0. This is 0, 1 and 0 plus 1 by 2. It is 0 only. Now, array of 0 is 1. Now, what you need to do? You got uh, the value which is greater than equal to 1. So, here n is 2, right? So, your value become n minus mid. That is 2 minus 0. That is 2. Okay. Now, you need to raise the low value. Sorry, you need to slow down. I mean, you need to decrease the high value, right? You got the better value. Now, you need to go for higher elegance. Okay. So this is 0, 0, again 1, again you got 2. Now what you need to do? You need to raise the high value now. Okay, mid minus 1, that is become minus 1. Now these two things are invalid. You are ending the loop here. Okay, let's try to write the binary search for this, binary search algorithm for this. Okay, so let's say greater elements. It is taking size and array along with the key. Okay. Now what is your intuition now? You need to count the number of elements that is greater than the given key. Okay. Greater than or equal to given key. Okay. Now you already know the search space, which starts with lower number 0 and high is n minus 1. Also, you know the initial answer. Initially, what you need to assume? You need to assume there is no number which is greater than k. Okay, by performing this operation we will get to know how many numbers are there. Okay, now let's go for binary search loop. What you need to do here, you need to iterate till your low is less than or equal to high. Okay, what you need to take here, you need to take mid as low plus high by 2. Okay, now you need to check if the given mid value, what you need to check, what we have checked here is the given mid value is greater than, okay, is greater than equal to the given k. Then what you need to do, you need to take that answer, you need to take that into the answer and update it as n minus mid, isn't it? Yes, you need to update it as n minus mid. Now after updating it, what you need to do, you need to reduce the high, right? You need to reduce the high by how much? Mid minus 1. Okay, else in this case what you need to do, you need to get, I'm sorry, you need to push the low to mid plus 1 by eliminating that low subspace, and finally you need to return answer. This answer is consisting of number of elements that is greater than or equal to the given one. Okay, clear? So this is simple greater elements ka algorithm. Okay, so in order to find how many elements in the array that is greater than the given k, this is the simple approach. Now let's discuss a very important concept: when to apply binary search. When to apply binary search. So far, we have seen a sorted, sorted kind of arrays, right? I am always defining there is a sorted array and there is a key. Now you need to find something. Is that a criteria? Let me write the first criteria. Is array need to be sorted? That is the first question I want to ask. Is array need to be sorted in order to do binary search? Not always. This one is not always. Why? Because our array is not going to be sorted always, but search space that we are doing search, this search space is always need to be inserted. So what is the main difference between search space and the array? So far we have seen every search space is an array, but we are going to see a new problem, that is there is uh, uh, search space is not going to be an array. Okay, we are going to see a new problem now. Okay, remember that in order to apply a binary search, arrays need not to be sorted. Okay, it is not a mandatory one. Array or else string, these things are need not to be sorted. The only thing is sorted is the search space. The search space you are looking for is main thing that need to be in sorted order. Okay, let's try to uh, do with an example. Just a second. Yeah, let's try to do this with an example. I defined the search space need to be sorted, right? Not array. Arrays need not to be insorted. Search space need to be insorted. Okay, let's try to do this with an example. Just give me a second. uh, yeah, let's try to solve a question known as aggressive curves. So what is this question states for is, like, you're going to give a stalls. Okay, that stalls is being installed in a line. Okay, initial or else in a road there are some stalls. Okay, let's say uh, there is a stall in one position. Okay, two, three, seven, 8 and 9. Okay, so there is a stall installed at first position, and there is a stall at second position, and there is a stall at fourth position, and there is a stall at eighth position. Also there is a stall at ninth position. So these are all stalls. So what you can do with the stalls is you can put a cow. Okay, let me define something cow like. Okay, I'm very bad at trying. Let me redefine it. Let's say, okay, this is a cow. You can assume this. This is a cow. Okay, this is the cow. Now these cows are very aggressive, so that what happen is you need to install k cows in the given array. Let's say my k is 3. Now there are 3 cows I need to install in this stalls. Okay, how I can install? I can install like this. Hmm, just a second. Okay, this cow is good. Okay, just a second, please. Yeah. Now, what happens is I need to install these cows in the stalls in such a way that these cows are very aggressive, right? So how I can install? Let me write different combinations. I can install these 3 cows from here. Okay. Now, if you see this, the distance between this and this is 1, right? Now the distance between this cow and this cow is 2. Okay. Now, if you take this, no, you need to maximize this distance. How you can maximize distance? This distance. Let me write all the combinations. This is one combination. Now let me try to install some more curves. This is combination 1. Now let's try to give combination 2. This distance is 1. This distance is, let's say, 6. Okay. Now combination 3. This is the combination 3. This is 1. This is 7. Okay. Now this is one combination. Now what is the other combination? Like combination 4. You can install cowset here. Okay. So this distance is, I'm sorry, it is at 4 now. So this distance is 3 and this distance is at 4. Okay. Now the other combination 5. This distance is 3. This distance is 5. Now one more combination that you can have. One cow is here. One cow is here. One cow is here. Now this distance is, I think it's an 8. Okay. So this can be 7 and this can be 1. Okay. So these are the different combinations that I can install all 3 my cows. Okay. These aggressive cows. Now if you carefully see this, my question here is I need to find maximum distance such that the minimum distance between the cows is going to be like adjusted. Like let me redefine it. I need to find maximum of minimum distances in every combination. Okay. So in this combination, what is the minimum I'll get? 1, right? Now in this combination, minimum is 1. Now in this combination, minimum is 1 again. Here in this combination, minimum is 3. In this combination, minimum is 3. Here minimum is 1. Now if you see this, what is the maximum out of all these minimums? What is the maximum out of all these minimums? That is 3, right? So you need to find the maximum possible combinations of minimum distances between those aggressive curves. That is the question. How you can do that? Like, let's say I'm giving an array. Let me take in the form of array the above given array only. It is going to be 1, 2, 4, 8, 9. Now my k is 3. Here I am getting output as what is the maximum minimum distances between every cow. That is 3 now. We have seen it. What is the maximum out of these minimums? 3, right? So we are getting 3. This is the given input. Now this is the given output. How we can do that? Here, if you go for traditional bind research, you don't get anything kind of any intuition here. Traditional bind research won't help to solve this kind of thing. No? So what is the one thing that you can follow? You need to, since I said binary search, but there is another approach for this as well. You can go through all possible combinations and finding the maximum out of it. That is one thing, but getting out all the possible combinations is itself is a difficult task, and it will going to be they're going to be like let's say for k cows, so we have nck kind of combinations. So you can install k cows by in n slots by using nck formula, right? So it is going to be n factorial divided by n factorial n minus k factorial. Sorry, k factorial and n minus k factorial. So if you take a big O notation of this, it's going to be order of n factorial. So it's going to be exponential time complexity. So what is the other approach that we can do? Let's see. In binary search, what is the main criteria to apply the binary search? Main criteria is defining search space itself, right? Defining a search space. That is itself a main criteria to do binary search in anything, not only in sorted array, in anything. Okay. So what is the search space here? Here, search space is not an array. Here, search space is not array. Here, search space is something we need to define now. Okay. Let's try to define it. I have placed cow set like now. I let's say I have stall set 1, 2, 4, 8, and 9. Okay. Now, if you see this, how can I define a search space based on this? I have k cows. Here k is 3. Okay, now I need to install this k cows. So what is my search space? My search space is always related to the distances that I'm looking for, right? So what is the maximum possible distance that I can put a cow? And one more thing, here in this question, there is only one cow allowed to fit in a stall. Okay, so you're not allowed to fit two cows in a single stall. That is not possible. Okay. Now let me define a search space. Let's say I have let's say I have only one cow. Then if I install one cow here, I don't need to go for any distance, right? So I can clearly say my lowest answer I'll get is 0. Okay. Now, let's say I have k as two cows. Now let's say how I can put two cows in order to get the maximum distance between them. What I can do, I can put one cow here and I can put other cow in the last end so that this distance is maximized, right? So this is the maximum distance that I can get. Like this is the one combination. The other combination will give this. This is one combination, and this is another combination. It will give 3, like this. Now, if you see this, you need to take maximum out of all these combinations. No? So which one will give maximum out of all these combinations? This thing. So I can clearly say this: if my k is 2, then the maximum possible answer that I'll get is, let's say this is an array. Now this is 0th element and this is first element. Let's say this is last element, not first element. This is last element. Now let's say my array is in sorted order only. Okay. For the problem solving, we are taking array is sorted order. Okay. Now what we are going to give? Our maximum possible answer is last element minus first element, right? Like the difference between the last element and the first element is known as my maximum possible answer. Okay, so this is highest possible answer. So you already know lowest possible answer as 0 and highest possible answer as this largest element minus the first element, last element minus the first element. Okay, so if you see this, for you, what is the logical boundaries? What is the logical boundaries now? Logical boundaries are between 0 to array of n minus 1 minus array of 0. Okay, so you got something like your answer is going to be lies always in between this. Your answer is going to be lies always in between this. Okay, so if you got sort space, then how you can apply binary search? You can easily apply binary search, right? So you figure it out the logical space, but what you need to figure it out? You need to figure it out, whether this, like let's say I'm every time I'm taking mid value, right? Now with this difference, with this mid difference, can I install all given cows or not? Can I install all given cows or not? That is the logical thing that you need to check every time. So every time we need to calculate the mid value in this search space. Now based on the difference, you are going to check, can I put it or not? Can I put all the cows in the stalls or not? Okay. So let's try to do that. Let's try to write the algorithm for this. So what you need to return here? You need to return an integer. Okay. Let's say aggressive cows. Now what it taking? It taking n, which is size of array, and the given array ARR along with the number of cows. Now what we need to do? We need to take. You need to define a binary search here, right? So what is the low value here? Here the low value is 0. That we figured it out. from the logical search space, and the high value is air, air of 0. I'm sorry, it's not 0, it's n minus 1 and air of 0. Okay. What happened is, let's say we have only one element, then those are the edge cases. So write the base cases here that are relevant. Okay. Let's say our array is greater than one element. Okay. And we need to iterate through. Now, initially, my answer is something, okay, something I don't know. That I'll figure it out like while deriving it. Okay. Now, what I need to do? I need to take mid value. How I can take the mid value? By adding low and high. Okay. By adding low and high. Now, I need to check if like let me name it. If can cows can be installed or not. How the cows can be installed with the given difference, right? So is cows are going to be installed with the given difference? Is it possible? That we are going to check. Okay, that we are going to check if this is possible. Okay, so what are the parameters that we need to give? This is the separate function that we need to build. Okay, let me give like a helper function. No, just a second. This is my helper function. It will tell whether I can install all the cows with the given difference of mid. Okay, so here also I can pass here k along with the difference. So what is the difference here? That is known as mid. Okay. So if it is possible, if it is giving true, then what you need to do? You need to go for maximum value, right? So that first I need to take my answer. My answer as mid here. Now what I need to do? I need to go for the bigger values. Since it is asked for maximum, right? Like see here I asked for maximum out of the minimum differences. So in order to go for the maximum, then what I need to do? I need to increase low value as mid plus 1. Okay. Else the other condition is high value as mid minus 1. Okay. Now finally you need to return your answer. Okay. So initially my answer can be plus infinite, something like this. Okay. Now we need to develop this helper function such that it will tell whether we can install all the cows in the given stalls or not. Okay. So let's try to do helper function as well. Helper function, what it will give? It will give you a boolean whether it can like all the cows installed or not. Okay, that is simple boolean that you can get. In helper function, what are the elements that we are taking? We are taking the size of the array along with array and k value. Also, we are going to take maths difference. Okay, let's say d maths I'll call. Okay, maths difference. Now we need to check whether we can incorporate k number of cows with the given difference of d maths. That is our target, right? So how we can do that? Let's try to see. Let's try to see with the example again. Okay. Now we have stall set this 9, 1, 2, 4, 8, and 9. Okay. Now initially your low value is 0 and high value is 9 minus 1, which is 8. Now, what is the mid value now? Let me write in the form of table that we are following from the beginning. Okay, so what is the low here? Let me write low, and high. Low value is 0 and high value is 9 minus 1, that is 8. And let's check mid value and let pass to the helper function. Okay, so low value is 0, high value is 8. So the mid value is 0 plus 8 divided by 2, that is 4. Now you need to check whether we can incorporate 3 cows. Here k is 3, right? So 3 cows in this distance or not. Okay, let's try to do that. Initially what I'll do is I'll try to put a cow here. Okay, now what happens is if I put a cow here, then what is the distance I am using? 1, right? But what is the maximum distance are allowed? 4. So what I'll do is I don't put the cow here since I have distance is 4, that is mid. Okay, what is the maximum distance? D max that we discussed in the parameter. No? So let me take D max. Maximum distance is allowed. Okay, that is 4. So can I put cow here? No, right? Why? Because it is in the distance of 1 only. Okay, so I can go till this point. Now if you see this distance is become 3, right? But still it is less than the given maximum. So what I'll do is I don't put the cow here as well. Now I'll go here. Now if you see this distance is become 7, which is bigger than the maximum distance allowed. So what happens is I don't put it here. I'll put here only. Okay. Now my new distance, like what is this distance? This distance is 4. Okay. Okay, now this distance is 4, which is the maximum one that is allowed. Okay, so that I can put one more cow here. Okay, so what happens is in this helper function, what I need to do is I'm getting a maximum distance. Now I need to put all the cows in such a way that these can be arranged or not. If it is arranged, then I need to give true. If it not, then I need to return false, right? So that is the criteria here. Okay, let's try to implement this. Just a second. Okay. Now in the helper function, what we need to do? We need to incorporate the cows in such a way that whether those are fitting or not, right? So initially, I'm going to count number of cows so far. Number of cows. Let's say, let me write it as cows only. Number of cows is put at 1. Okay. Now, and let's say current distance. Okay. Let's say my current distance is I am at 0th index, right? So I can say at 0th index, I'm having the cow, like I put it the cow there. Now I started from first index and I am going to till n minus 1. I'm going to check. Let me write it clearly. Okay, this is cows. Now what I'm going to do, I'm going to check whether these are fittable or not. Okay, like if my current distance minus, you know, what is this current value, like air of I, right? Yeah, current value. If it is, if it is exceeding the maximum distance allowed, if it is exceeding the maximum distance allowed, then what you need to do, you need to increase the count, right? You need to increase cows ka count. Why? Because you're not allowed to do, you're not allowed to install any cow that is the bigger than the given distance, right? So that is not allowed. So what you need to do here, you need to install another curve here. How you can install another curve? By incrementing the cows value. Okay. Now after installing new curve, then you are going to, your current value is going to become array of I, right? Your distance ka current value. Okay. Now one more thing you need to check here. If you are installing more curves, like you are allowed to install only 3 curves, right? If you are installing more curves, if you are installing more clause greater than k, then you need to immediately return false there. Why? Because that is not allowed. Na? You're not allowed to install cows more than that are that you need to allocate. Okay, that is not allowed. Okay, so this is the simple approach. Now, if everything goes well, then you need to return true. Okay. So this helper function will help you to get whether you can install k number of curves with the given distance d, the maximum given distance d. Okay, clear? I think it is clear. So that what happens is every time we are going to eliminate like some sort of answers by using binary search in this help by using the helper function and this with this binary search algorithm. So what is the time complexity of this? This helper function time complexity is order of n. Why? Because every time we are going through all the elements in the given array, right? And this binary search algorithm ka time complexity order of log n. So overall time complexity of this approach is order of n into log n. So earlier time complexity is order of n factorial. Now it got reduced to order of n log n with small kind of observations in the binary search. This is like you can yeah. Now you can assume like binary search can be done in such a way that there is need not to be sorted. Arrays need not to be sorted, right? Only logical space need to be sorted. Okay, that is about binary search today.